Hello everyone, welcome once again to Nated Engineering. We are still doing friction engineering science N3, and today we will be looking at a question from the question paper that was written on the 8th of April 2015. It's question number 4, and we are going to start from 4.1, which reads as follows. Name 4 principles of kinetic friction. We know we have two types of friction. We have static friction and we have kinetic friction. Static friction is the friction that a body is subjected to as it is stationary. And kinetic friction is the friction that a body is subjected to as it starts moving or when it is in motion. So from there, we are going to, they said they want 4 principles of kinetic friction. The first one, friction depends on the nature of the surface in contact. How rough or smooth a surface is does contribute towards the amount of friction that will be experienced. Number 2, friction is independent of the speed. Number 3, friction is independent of the size of the area in contact. The last one, friction is proportional to the perpendicular force between the surfaces. And then we move on to 4.2. 4.2, they are giving us a scenario. During an experiment on an adjustable inclined plane, a block weighing 1.6 tons was placed on the plane. The incline is at an angle of 20 degrees to the horizontal. And then we are given, they say, if the frictional force is 225 newtons, determine the following. Those are the questions. Question number 1, the weight component of the block parallel to the plane. Number 2, the weight component of the block perpendicular to the plane. Number 3, the smallest force required to pull the block upward along the plane. Number 4, the power if the block moves at a constant speed of 10 meters per second. And then this is the data. This is what they are giving to us. They are giving mass to us and it is in tons. So we have to convert it to kg, to kilograms. By times, so to do that, we times by 1000. We convert to kilograms because that is what we use, or that's the SI unit that we use on our equations. And then they're telling us that the slope is 20 degrees. They're giving us frictional force, which is 225 newtons. So this is the remove this. This is what they are giving to us. So we cannot include the frictional force just yet. The diagram is like this. This is what they are giving to us, and there is normal reaction. We know that if a block is resting on an incline, before there is any external force that is applied to the block, these 3 forces are always acting on the block, and they are always in these directions. There is always a normal reaction, there is always mg cos theta, and there is always mg sin theta. And we are having the angle given to us as 20 degrees. So this is the diagram that we are going to draw based on what we are given on the what was described to us. So what's going to happen now is we go to 4.2.1. They say calculate the weight component of the block parallel to the plane. We know that these two are the weight components, and we know that we have this which is parallel and we have this which is perpendicular. So they are looking for the parallel plane. Parallel is this one, The plane that we're working with, remember, is this one. Therefore, the one which is parallel to the plane will be mg sine theta. Meaning what they are asking us to calculate here is mg sine theta. The value of our mass is 1,600. Our gravitational acceleration is 9.8. Sine theta, our theta is 20. And this, according to my calculator, I got that it is 5,362.876, and it's a Newton. We go to the second question. 5.2.2. They say the weight, determine the weight component of the block perpendicular to the plane. Perpendicular to the plane is this one, mg cos theta. Meaning here we are asked to calculate for mg cos theta. Our m is 1,600. Our gravitational acceleration 9.6, and then we have cos, and then our Newton, our slope theta is 20 degrees. And according to my calculator again, I got that this is equals to 1473 4.380 and is a Newton. The third question, they are asking us to calculate for the smallest force required to pull the block upward along the plane. We then now are told about an external force. We are going to give it the symbol F. We're going to name it force F. It's pulling upward, meaning we now have the direction of the frictional force, because we know if this block is pulling upward, meaning the motion of the block is in that direction. What is the one thing that we know about finding the direction of the frictional force is that the frictional force will always oppose this motion, meaning if the block is moving in the direction of force F, the frictional force will be moving in the opposite direction, which will be in the direction of mg sine theta. Therefore, our 4.2.3 will be F. Here we are going to focus on the forces that are parallel to the plane we are working with, and we are going to equate the forces that are going upward, and they are going to be equals to the forces that are going downward, down the slope. F is the only force that will be going up the slope. We are going to say equals to the two forces that will be going down the slope. They will be positive to each other, and they will be on the same side of the equal sign because they are going in the same direction. Yeah, we are going to add them. That's what positive to each other. That's what I meant by positive to each other. So it's going to be frictional force plus mg sine theta. Our frictional force were given as 225. Our mass is 1,600. Our gravitational acceleration is 9.8. Then it's sine theta. Our theta is 20. From here, I got that in the place of this, because we already calculated for mg sine theta, you can put this. It's going to give you the same thing. So whether you just say, instead of substituting this whole thing, you say I already have the value, or you do it like this. There's no difference as long as you get the correct answer. Either way, you are going to get the same value. So the answer, which is the force, the smallest force that is required to pull this block up the slope, it's going to be 5587.876, and that is a Newton. And then we go to the last question. They say calculate the power if the block moves at a constant speed of 10 meters per second. So we are going to get rid of this. It's 4.2.4. We're using the formula for power as force times V. We have the force, we are given the velocity as what? 10 meters per second. We have the force we just calculated. So we are going to end up with, we're going to substitute 5,587.876 times 10. And then our final answer, we are going to end up with 55.879. That will be kilowatts. You leave it in kilowatts or watts, it's up to you. I did it kilowatts because the number was too long. And then this is what we end up for question number 4.2.4, which is basically the end, the last question on this video, and that means the end of our video. I will see you on the next one.